Welcome to this tutorial, guys. Basically, I'm going to go through special angle triangles and then I'm going to do some questions, 4 of them, but nothing too interesting. Okay, so starting with special angle triangles. These triangles you guys need to learn, know them off by heart, but if you do forget them, it's not train smash and you can actually come up with them in the exam or test. It just takes a bit of time. Okay, so the special angle triangles. Okay, so what are special angles? Special angles are angles that we often work with, which are 0 degrees. Let's take that off for now. 0 degrees, 30, 45 degrees, 90 degrees, let's go 60 degrees, 60 degrees, and 90 degrees. Okay, so don't think I've forgotten any of them. Okay, so the special angle triangles we get from the relationship that we have here of cos, sine and cos graphs, as well as a unit circle. So what is a unit circle? A unit circle is a circle, that's not a circle, is, let's see, is a circle where the formula is x squared plus y squared equals 1. So essentially a circle with radius equal to 1. Okay, so let's start by, okay, so there's 2 separate triangles that you need to know how to draw. Okay, so the first triangle, let's start with, okay, so the first triangle, okay, so the first triangle has an angle of 30 degrees, 60 degrees, and 90 degrees. Okay, so both special angle triangles have 90 degrees. Okay, so and we have the triangle going 1. So the length of that side is 1, the length of this side is square root of 3, and the length of this side is 2. Okay, the second triangle, we have, not so great, let's take that out, let's try to get it better. Okay, I'll give it one more shot and then I'm going to give up and hope you guys understand. But essentially, yeah, there, that's pretty nice. We have a 45 degree, and 90 degree triangle. So an isosceles triangle. So the length of this side is 1, the length of this side is 1, and the length of this side is square root of 2. Okay, so let's just put our radians in here as well. So for this one we have pi over 6, pi over 3, and pi over 2. And we have pi over 2, pi over 2, and rather pi over 4, pi over 4, and pi over 2. Okay, the second triangle can actually be redrawn as well, like this, with 45, 45, and 90, and 2 square root of 2 and square root of 2. Okay, so you guys can pick whichever one you guys want to use. Both of them are essentially the same thing. But for now, I'll use those triangles. Okay, so how do we get to these values? So we need to know some relationships. So we know that sine theta is equal to your opposite side of a triangle over your hypotenuse, and cos theta is equal to your adjacent side times the hypotenuse, and your tan theta is equal to your opposite over your adjacent. Okay, so let's put in the sine 30. So let's get sine 30. Sine of 30 is equal to, so if you put that in, put that into your calculator, and sine of 30 is 1 over 2. So let's see if that works for our triangle. So we have 30 degrees, so our base point, let's change colors, our base point is this angle here, and sine is opposite, which is 1, over hypotenuse, which is 2. So it works. Now let's try a different one. Let's try tan of 45 degrees. Okay, tan of 45 degrees, if you put it into your calculator, is equal to 1. So if we have this triangle here, 45 degrees is there, is opposite, which is 1 over 1, which comes to this answer here, which is 1. And if we use this triangle, again, our angle, we can pick one. Let's pick this one, 45 rather. Opposite, square root of 2 over square root of 2, so square root of 2 over square root of 2, which is also equal to 1. So again, oopsie, we can use any of the triangles that we so please. Okay, and just for the last one, let's see, let's take cos of 60. So our base angle is this angle right here, and we want, if we try the calculator, cos of 60 is equal to 1 over 2. So opposite, or adjacent rather, which is 1, and over the hypotenuse, which is 2. So we get 1 over 2. So we see that our triangles actually work, which is quite nice. Okay, so let's remove all of this and let's get into some questions. Okay, similarly, if we used radians, we get the same answers. And the questions I have for you guys are actually based on radians. Okay, so at this point, I suggest you guys take down these triangles. Let's see, there's your 2 triangles, nice and beautifully. Okay, and now, okay, there's your triangles. Hope you took it down. Pause the video, take it down, and now let's do some questions. Okay, so the questions. The questions again, pause the video, do the questions, and then see if you get the same answers. Well, that's what I recommend. Okay, so there's 4 questions. Let's start with the first question. Okay, so sine of 45. Sine of pi over 4. So, okay, so first one I'll walk through with you guys, doing all the angles and whatever, and then with the next questions, I'm just going to write the answers and hopefully you guys get the same ones. Okay, so let's sine of pi over 4. So first we go and we get our pi over 4, and sine is opposite over hypotenuse, so it's 1 over square root 2. That's that. Okay, times cos of pi over 3. So we go to our triangle, look for pi over 3, that's that angle right there, and we're looking for cos. So cos is adjacent over hypotenuse, which is 1 over 2. So times 1 over 2, and tan of 45, so 45, and we're looking for tan. Tan of this angle here, tan of 45 is 1 over 1, which is equal to 1. Okay, so this is equal to 1 over 2 square root 2 times 1 over 2, which is equal to 1 over 2 square root 2. Okay, so great. But if we put this into our calculator, the answer we get is, so if you put that straight into your calculator, you get square root 2 over 4. So what's happened here? These look completely different. So have I taught you the wrong thing? Well, let's see. So all the calculator has done here is, okay, so these questions you're supposed to do without a calculator first of all, but obviously use a calculator to check your answers. So in a test, you put this into a calculator and you see that you got square root 2 over 4. So you think you might be wrong. But all the calculator has done is got rid of the square root sign in the bottom. So it's multiplied by square root 2 over square root 2. And the answer you get is square root 2 over 2, square root 2 times square root 2 is equal to 2, which is square root 2 over 4. Obviously, if you're not supposed to use a calculator, I think going this far is satisfactory, but also taking out the square root sign in the denominator isn't wrong. So either of these answers should be correct. Cool stuff. So I'm just going to leave it as square root 2 over 4. And that's the answer. Okay, cool. So not too bad. Let's look at this next question. So now we've got a cosec pi over 4 times cos pi over 2 times, divided by tan pi over 6. So the first thing we need to do is we need to get rid of this cosec. How do we do that? Cosec is, let's see if we have it here, there we go, 1 over sine. So we write it like that. So 1 over sine pi over 4 times cos pi over 2 divided by tan pi over 6. Okay. So what is sine pi over 4? It's equal to 1 over. So let's go to our sine pi over 4 is sine, here's our angle, 1 over square root 2. So we have 1 over square root 2 times cos, which is just cos of pi over 2. So okay, so cos of pi over 2, unfortunately in these triangles we can't actually work that out. But if we use our graph, what is cos of pi over 2? That is 0. So that's that point right here. So if we go back, cos of pi over 2 is 0 over, I'm not even gonna, okay, let's just do it, pi as tan of pi over 6. So we go find pi over 6, tan is opposite over adjacent, which is 1 over square root 3. Obviously in the numerator we have a 0, so the answer is equal to 0. But obviously if you knew that cos pi over 2 is equal to 0, then you could have just written it as 0 from the beginning, because anything 0 over anything is just equal to 0. Okay, so the next question. Okay, so I just want you to note that these two questions are identical in that we have cot, we've got sec, and we've got cosec. The only difference is the angles, and I'm going to do that, do both questions, and I'm going to show you why they differ slightly. Cool stuff. Okay, so this has got lots of converting. First, we're going to convert cot into 1 over tan. So we start off with 1 over tan pi over 6 times 1 over cos pi over 4 divided by cosec, which is 1 over sine pi over 3. Cool stuff. Then what I'm going to do is I'm going to take this sine and move it up. So to do that, we have 1 over tan pi over 6 times cos pi over 4 times sine pi over 3. Okay, so we have, let's write it nicely, sine pi over 3 divided by tan pi over 6 times cos pi over 4. Okay, so now you guys can go to your special angle triangles and you get sine pi over 3 is square root of 3 over 2 divided by tan pi over 6 is 1 over square root of 3 times 1 over, and cot of pi over 4 is equal to 1 over square root of 2. Okay, so let me get a bit more space again. Okay, so moving on, we have square root 3 over 2 times, and I'm going to multiply this, so we get square root of 3 times square root of 2 over 1, which is equal to 3 square root of 2 over 2. Okay, good stuff. And that is your final answer. Okay, looking at this last question. Okay, again, I'm going to start by converting all of these into sine, cos, and tans. So we have 1 over tan pi over 4 times 1 over cos pi over 4 over 1 over sine pi over 4. Okay, then what I'm going to do is I'm going to write tan is equal to, let's see, opposite over adjacent, or tan is equal to, I hope you guys know this, tan theta equals sine theta over cos theta. So I'm going to write that as 1 over sine theta over cos theta times, the sine theta comes to the top. So I've replaced pi over 4 with theta because all of them are pi over 4, and then I'll replace it back over cos theta. Okay, I'm going to change the order of this fraction, so we get cos theta over sine theta times sine theta over cos theta. Okay, and what we end up with are things cancelling. The only reason we can cancel them is because these angles are the same. So let me actually just write it out. So we have cos pi over 4 times sine pi over 4 over sine pi over 4 times cos pi over 4. Okay, and cos pi over 4 cancels with cos pi over 4, sine pi over 4 cancels with sine pi over 4, and our answer is 1. Cool stuff. Okay, so in this question here, we couldn't cancel things because we had different angles. So only if the angles are the same can we actually cancel them. Okay. Cool stuff. Yeah. Okay. I just want to speak here a little bit. Okay, this is often, sine theta is often written as y over r. Cos theta is written as x over r. And tan theta is written as y. Okay, so tan theta can be written as, like I said before, sine theta over cos theta, which is equal to y over r divided by x over r, which is equal to y over r times r over x. These two cancel, so we're left with y over x. And the way we get that relationship is we just have a circle. So where's my circle? So we have that unit circle, and if we just draw a set of axes, that's our x-axis, that's our y-axis, and let's say we make a triangle in here. This is our radius, this is our x value, and this is our y value. So if we put theta in there, sine is y over r, cos is x over r. Yeah, and there we go. Okay, so a little bit of work here and there, but it's important to know how to do these. I'd say most of this was fairly basic, with the last ones being a little bit more work. But I hope you guys found this tutorial useful, and I hope it helps. In the next tutorial, I will cover, well, let me maybe let you guys think of something, but let's think of this. So in the next tutorial, or in a future tutorial, I'm going to explain why sine theta to the -1 is not equal to sine theta to the -1, which is not equal to sine theta to the -1. So you guys can maybe think of that and try and understand why they're not equal, but I will explain it in a future video. Okay, thanks for watching, guys.